Welcome to the Crazy Hat Chemist, where everything you need to know about chemistry is right here on my YouTube channel. So here we go. We're going to do an awesome worksheet here today, and it's going to be how to solve using density worksheet number 1. All right, so let's get into this. I'm going to do some rearranging of equations first, and then we are going to do some mathematical problems. Before you actually watch this video, you probably need to do watching 2 sets of videos first. And they're also on my YouTube channel. That is the Crazy Hat Chemist. The Crazy Hat Chemist. That's right, folks. So the 2 sets of videos that you need to watch are the following. You need to watch how to round numbers correctly. And you also need to, besides how to round numbers correctly, you need to watch the video series on how to determine significant figures. That's very critical. We'll be using both of those concepts within this video. All right, so let's get started here and plug on through these problems here. So the first thing that we're going to be doing is solving for the equations and the units that are associated with each equation. That's going to be critical. Okay, so I'm assuming that all of you have a heart, and that's probably very true. You all have a heart, and there's a picture of a heart. So I always recommend, have a heart, draw a heart, beautiful thing. Except that as your chemistry teacher, I am going to take my very sharp shun knife, and I'm going to slice your heart, but I'm going to slice your heart in a horizontal fashion. Okay, so I'm going to slice your heart just like that. Boom. Sliced your heart. Well, this is very important because this tells you the density equation. So density is equal to, and you can see this, that's an M on the top of that slice. So that's an M, and that's a V on the lower portion of that slice. So that tells you what the density equation is, and that is density is equal to M, that's mass, over V, that's volume. And the units for density is going to be the following. It's going to be grams per milliliter, or we are going to write grams per cubic centimeter. Now, there are other units of density. There's no doubt about that. However, this is what we're going to be using on this worksheet here, okay? To keep it simple, stupid. All right, so here we go. So from this density equation that we have written down here, what we're going to do is rewrite this entire equation right over here. So we're going to have density is equal to mass over volume. So if you had the number, let's say 2, and what is the denominator of 2? That's right, folks. Yep, that is a big fat 1. Okay, so what we're going to do is we're going to use that concept here and say, what is the denominator of D? That is 1. So I'm going to place that right there like that. What we're looking to do right now is we solved for the density equation. First of all, we got that with your heart. And then now what we're going to do is we are going to rearrange the density equation and solve for mass. So we need to isolate the M, that is the mass. And so how we're going to do this is we're going to cross multiply, and that will allow me to do M times 1, which is M, is equal to D times V. D times V. So that's going to be my mass equation. So I'm going to write that down. M, that's for mass. Density, or D, that's for density, and V, that's for volume. And the units for mass are going to be grams. All right, fantastic. All right, so we're going to move this paper on up here because we need a little bit more space, and I want to keep the same zooming that I currently have. So we're going to scroll this on up here, and we're going to look to the next portion of this. So what we're going to do, just like what we did before, we took the density equation, rewrote it down here. We're going to take this mass equation right here and rewrite it right here. So let's do that. We have mass is equal to density times volume. And now what we're looking to do is we're going to rearrange this density equation and solve for volume. So I'm going to balloon this, put it in a cloud. I'm solving for that. So it's density times volume. What's the opposite mathematical function from multiplication? That would be division. So I'm hoping that you do remember your Algebra 1 skills, and that's how we are solving for these equations here. So we're going to divide. We're doing the opposite function of multiplication, and that's dividing. So we're going to divide both sides by the density. That will allow us to cancel out the density right here. And now I will have volume is equal to mass over density. And there's my volume equation. I'm going to rewrite this to make it look really nice and pretty. And so that will be volume is equal to mass over density. And the units of volume in which we'll be using on this worksheet will be milliliters or cubic centimeters, just like that. Okay. All right, fantastic. So what I'm going to do right now is I am going to zoom on out here so that I see all three of these equations. That's going to be really important here because we're going to make use of all three of these equations. So let's just go over them real quickly here. To solve for the density equation, what we're doing is we're taking a heart. We're slicing that heart horizontally. That will give me my M and my V. The M is in the numerator, the V is in the denominator. So that's density is equal to mass over volume. I'm going to write that down. Density is equal to mass over volume. The units for density are going to be grams per mil or grams per cubic centimeter. Then what we have is we're going to rewrite this density equation right down here. Remember, the denominator of anything is 1, so that's why that's a 1 there. So I got density is equal to mass over volume. I'm going to solve for the mass. So I'm going to cross multiply because I got a fraction is equal to a fraction. Cross multiply, I get mass times 1, which is m, is equal to density times volume. So that's why I got mass is equal to density times volume. And the units for that are going to be grams. Then what we have is we're going to take this mass equation that we have, that we've rearranged the density equation, we're going to write it down here. Mass is equal to density times volume. So density times volume, that's multiplication. I'm going to do the opposite mathematical function, which is division. So I'm going to divide both sides by d because I want to isolate the v. That will cancel out these d terms, and now I'm going to have mass over density is equal to v. I'm going to make it look pretty like what I have on all my other ones, and that's a volume is equal to mass over density. And the units for that is milliliters or cubic centimeters. Perfect. So now we have the three mathematical relationships associated with density, mass, and volume, and we also have their units associated with those. So what we're going to do now is we're going to scroll this up here just a little bit, and I'm going to read a couple of notes. It says, note number 1, the unit of volume that is typically used in chemistry is the milliliter, abbreviated as ml. The milliliter is defined as a cube 1 centimeter on edge. Therefore, the volume of this same cube is 1 cubic centimeter, which is equal to 1 milliliter. So, for example, if we had a cube, and I'll just take this cube right here that my son made, really super cool here. He made it in his metal shop. Now, it is most certainly not the perfect cube, but it will suffice with this little project here. Let's pretend that this is 1 centimeter. Okay, and then then this is also 1 centimeter. And then this is 1 centimeter. So that's 1 centimeter by 1 centimeter by 1 centimeter. That's 1 cubic centimeter. So that's 1 centimeter times 1 centimeter times 1 centimeter, which is 1 times 1 times 1, which is 1. And that's a cubic centimeter. That is 1 milliliter. All right, sweet. All right, let's pull this back off of the table there. So now what we're going to do is we're going to scroll this down here a little bit more, and it says solve for requested component, include the correct number of significant figures and units in your answer. So what we have here is 10 problems to solve. Okay, so we've got 10 problems that we're going to solve, and we're going to do these 10 problems. We're going to solve for what is unknown, and we're going to be using these three equations that we previously derived. All right, so remember, what are you watching? You are watching The Crazy Hat Chemist, and please watch all my videos on YouTube. Please like and subscribe. I'd greatly appreciate that. That would certainly help me out. And maybe one of these days, I might be able to buy myself a Starbucks coffee. All right, so here we go. We're going to zoom this in, and we're going to do each one of these problems on a separate sheet of paper, but referring back to this piece of paper here frequently. All right, so let's zoom on in, and we're going to start doing these mathematical problems here. That's very important. We're going to do this first one right here. All right, so I'm going to cover everything else up so we just see this first problem. And it says an object is 13.2 G, that's grams, and at 2.5 milliliters, calculate the density. So I'm going to just highlight what we're supposed to solve for. Okay, perfect, just like that. All right, so what we're going to do is, it says calculate the density. So what we're going to do is we're going to scroll this piece of paper on up, and we're going to say, what is the density equation? It's density is equal to mass over volume. So I'm going to rewrite that. That's going to be really important here. Density is equal to mass over volume. Why am I writing that? Because it says calculate the density. Okay, now this set of units right here, that is grams. So I need to figure out what that is. And so what we're going to be using, is it grams? No, it is grams. Grams is a mass. That's what we know. So grams tells me, so this unit of grams tells me this is a mass. Okay. Then these units right over here that I'm going to highlight, these are milliliters. So what is milliliters? What is milliliters? Milliliters is a volume. So that tells me that this number here is a volume. Okay, so that's going to be really simple, hopefully. Okay, all right, so let's give this problem a try and see if we can solve it here. All right, let's straighten this up here. Here we go. Density is equal to mass over volume. What I'm going to do is I'm going to substitute in the 13.2 grams in for the mass, 13.2 grams. And then I'm going to substitute in the 2.5 milliliters, 2.5 milliliters for the volume. Perfect. All right. Now what we're going to do is we are going to pull out our handy dandy calculator, and we're going to plug in these values. That's 13.2 divided by 2.5, and I am going to get the number 5.28. Now, again, remember, you need to have watched previous videos that I have made, and that is on rounding and significant figures. So that's really important. So what we need to do is we need to round this number correctly and to use the correct number of significant figures. So the number of significant figures here is 3. That's 1, 2, 3, 3 significant figures. The number of significant figures in this number is 1, 2, 2 significant figures. We're going to be using the fewest number of significant figures, which is 2. So I'm going to say 1, 2 significant figures. That means I am rounding with that 8. This 8 is 5 or greater, so I'm going to add 1 to the preceding digit. This 2 is going to become a 3. So I'm going to write this number down, 5.2, and then I need the correct units for density. And if you want, you can always scroll over here and say, what are the units for density? Grams per mil or grams per cubic centimeter. For this particular problem, that will be grams per milliliter, grams per milliliter, just like that. And I'm going to circle that. That way I know what my answer is. Now I have the correctly rounded answer with the correct set of units. All right. So that's problem number 1, by the way. All right. So let's cruise on, and we're going to cruise on to problem number 2, and we're just going to cruise on through these problems here. These shouldn't be too bad. All right. Problem number 2. It says an object occupies 2.06 milliliters. So these milliliters tell me what this is. So what has milliliters? What has milliliters is a volume. So I'm just going to write a V next to that because that's volume. And 0.39 grams per mil. Grams per mil, what do those units correspond to? Grams per mil corresponds to a density. So that means that we know that this 0.39 is a density. And then it says calculate the mass. So that is what I'm asked to solve for. So now I'm going to find the mass equation. What is the mass equation? It's right here. Mass is equal to density times volume. So I'm going to rewrite that mass equation. So mass is equal to density times volume, just like that. Okay, so let's see if we can get just this single problem up here and work on just this one. Perfect. So mass is equal to, I need to find the density. That's 0.39, that's grams per milliliter, times the 2.06 milliliters. Perfect. I've stuffed that into the equation, density times the volume. Now what we're going to do is we're going to plug this into our calculator, 0.39 times 2.06, and I'm going to get the following number in my calculator, which is an unrounded number. So you should be getting that same number if you're following along with your calculator. So now what we're going to do is we are going to look at the number of significant figures. Leading zeros do not count. The 3 and the 9 count. That's 2 significant figures. 2.06, that is a captive zero. Captive zeros count, so that's 3 significant figures. The fewest number of significant figures I have in this problem is 2. So I'm going to round this number to 2 significant figures. Remember, leading zeros do not count. That's 1 and 2 significant figures. I am rounding with that 3. That is less than 5, so I'm going to chop the numbers. So I'm going to have 0.8 and 0. And then you can look at the units of which are here. The milliliters cancels out. I'm left with grams. The other way to do that is I am solving for a mass. What should be the units of mass? Mass should have the units of grams. So that means that I should have the units of grams on my final answer on this problem. So let's plug in those units for grams just like that and circle our answer to make sure that everybody's happy. Perfect. That's number 2. Let's see if we can scroll on and continue to do problem number 3. All right. So just a rearrangement of the little papers here, just so that it all is very easy here. Okay, so let's do problem number 3 here. Let's just show off number 3. Here we go. And it says an object is 19.75 grams per mil. So these units of grams per mil tells me exactly what this is. So what has grams per mil? What has grams per mil? Oh, grams per mil, that is a density. So that means that this 19.75, let's just show that right here. 19.75, that is a density because it has units of grams per mil. Then we have 4.07 grams, and what is that? Grams. Grams is a mass. So that is what we have for a mass. So this is a mass. So, and then what we are solving for here is, well, it says, what is the volume? And so I need to write down the volume equation. So let's find out what the volume equation is. Here's the volume equation. Volume is equal to mass over density. So we're going to be using that right here. So let's write that down. Volume is equal to mass over density. And what we're going to do is we are going to plug in both of these things in their appropriate spots. So that is 4.07 grams. That's a mass. 4.07 grams. That's in the numerator, and the denominator has 19.75 grams per milliliter, just like that. Okay. All right. So now what we're going to do is we are going to plug these numbers in our calculator, and we're going to get some unrounded number that we're going to have to work with right here. So let's see what we got. That's 4.07 divided by 19.75, and I'm going to get this giant long number, and it will be 0.206075949. And there are more numbers beyond that, but we don't need to worry about that. What we're going to do is look at how many significant figures are there in this number. That's 1, 2, 3 significant figures. How many significant figures in this number? That's 1, 2, 3, 4 significant figures. The fewest number of significant figures is 3. Leading zeros don't count, so it's 1, 2, 3. I'm rounding with that 0. That is 0.206. And then I need to figure out what are the units for volume that are associated with this. And so I'm going to scroll this right on back up here again and find my volume equation. And what are the units for volume? That's either milliliters or cubic centimeters. So in this particular case, it's milliliters. And I'm going to circle that, and I'm going to get my answer here in 3 significant figures. Now, another way to look at your units here, if you're confused by that, you you have a denominator in the fraction, so you would actually have to multiply by the reciprocal of that in the numerator and the denominator, and that would cancel out the mils and the grams, so that the denominator has 1. Then the grams cancel out here, and you're left with milliliters. That's another way to look at that. So hopefully that works for you. All right, so let's see if we can keep on going for our next problem. Hold on just a second. Okay, so here we go. Our next problem here, it says a gold bar is 12,400 grams. What is the volume? So let's highlight what that is. What is the volume? If the density is 19.3 grams per cubic centimeter. Okay, so grams, we need to figure out what that is. Grams is oh yes, that's right. Grams is a mass. Okay, and grams per cubic centimeter, grams per cubic centimeter, grams per cubic centimeter, that's a density. Just like the problem says, it's a density, but just making sure. Okay, so problem number 3, this grams is a mass, and this grams per cubic centimeter, that is a density, just like that. So it says, what is the volume? So I need to find the volume equation. What is the volume equation? Volume is equal to mass over density. All right, so I'm going to rewrite that. Volume. Let's see here. Here we go. Volume is equal to mass over density. Is equal to. All right, so we're going to plug in the mass at 12,400 grams divided by the density at 19.3 grams per cubic centimeter. All right, so what we're going to do is we're going to plug these into our calculator. That's 12,400 divided by 19.3, and I am going to get a number 642.4870,46632. So now what we need to do is figure out how many significant figures. So the 1, the 2, and the 4 count, but the 2 zeros that are trailing don't count because there's no decimal in the number. So this has 3 significant figures, and this is a 1, a 9, and a 3, and they all count, so that's 3 significant figures. So I have 3 significant figures on every part of this one. So hold on just a second, we'll continue this. Right, so here we go. So 3 significant figures, in both of them, they have the equal number of significant figures. So I'm going to pick 3 significant figures, 1, 2, 3, and I'm rounding with that 4. That 4 is less than 5, so I'm going to chop the number. So I'm going to get 642, and then the units for volume will be cubic centimeters. And you can actually solve for the units here, just like what we did on the last problem, that is multiply by the reciprocal, cubic centimeters over grams. That cancels both of the denominator terms out. Cubic centimeters over grams, and the grams cancel out, and I'm left with cubic centimeters. Perfect. So that is problem number 4. So let's move on to problem number 5. And here we go. Problem number 5. So let's scroll this up just a little bit. So we got problem number 5. It says, what is the mass? So I'm going to highlight again what we are solving for. What is the mass? Okay, so what is the mass of 22 milliliters of seawater if the density is 1.03 grams per mil? Well, it does say that the density is 1.03 grams per mil. So we know that this is a density, just like on the last problem, it actually said the word density. Milliliters, what does that correspond to? Well, we need to figure that out. Milliliters corresponds to a volume. So we've got that part nailed now. So now we know that the 22 mils is a volume. We are solving for the mass. So let's write down the mass equation. That will be really important. So we scroll on up over here. Mass is equal to density times volume. So I'm going to rewrite that mass equation as is appropriate. So mass is equal to density times volume. So what we have here is we are going to substitute in the density, which is equal to 1.03 grams per mil. That's the density. times the volume, that's 22 milliliters. Fantastic. So I've substituted in the density, I've substituted in the volume. We can actually look at significant figures. That's a 1, 2, 3 significant figures, because that's a captive zero and captive zeros count. This is 2 significant figures right here. You should also see that the units of milliliters will cancel out. I'll be left with grams, and that is a mass. Okay, so I'm going to plug this into our calculator and see what we get. 1.03 times 22, and we will get the following number. 22.66. And then we need to round this to 2 significant figures, because it's the fewest number of significant figures. 1, 2 significant figures. I am rounding with that 6, that is 5 or greater. I'm going to add 1 to the preceding digit. This 2 will become a 3. So I'll have 23, and then I will have the units that didn't cancel out, and that will be grams. You can double check on this and say, what are the units for mass? And the units for mass would be, oh yeah, that's right, that's grams. That looks good. And we just did that problem correctly. All right, congratulations, folks. We are actually halfway done with this worksheet, which isn't too bad. So we only have 5 more problems to do. Let's see if we can cruise on through those 5 more problems. All right. So here we go. We're going to do problem number 6. All right. Problem number 6, it says a typical feather queen pillow has a size of 0.0025 grams per cubic centimeter. What is the volume? So I'm going to highlight what we're solving for. What is the volume? And if the pillow is 93.75 grams. So let's see if we can solve this one here. All right, so let's see, we've got our pillow problem to deal with right here. Hopefully you're not getting too sleepy. So we're going to solve for the volume. So what we're going to do is we're going to scroll this on up and find the volume equation. Volume is equal to mass over density. So I'm going to be using that most certainly, since it's a volume. All right, so let's see here. Volume is equal to mass over density. And so what we need to do is grams per cubic centimeter. What is that? Grams, here we go, grams per cubic centimeter. What is that? That is a density. So we know that this number right here, 0.0025 grams per cubic centimeter, that is a density. Then we need to figure out the 93.75 grams. And the 93.75 grams is a mass. So therefore, I know that that is a mass. All right, so that means that this number is a mass. So I'm going to plug these numbers into this equation here as is appropriate. So I've got the mass at 93.75 grams divided by 0.0025 grams per cubic centimeter. Perfect. So now what we're going to do is we're going to plug this stuff into our calculator here, and we're going to get a number. So volume is equal to, we're going to say 93.75 divided by 0.0025. And we're going to get a number right here. That number that's in my calculator is 37,500. Okay, and we're going to look at the number of significant figures we have. We got 1, 2, 3, 4 significant figures. Leading zeros do not count for significant figures, so that's 1 and 2 significant figures. So that means I need to round my answer to 1, 2 significant figures. I'm looking at that 5 for rounding. So I know this is not dollars, but just imagine this as dollars. So when we round, we're going to round imagining dollars. So this $37,500. Since this 5 is 5 or greater, I'm going to add 1 to the preceding digit. This 7 will become an 8. So 38. Now, if you gave me $37,500 and I were to round it and give you back $38, would you be happy? Heck no, absolutely not. In fact, there's a comma right there. So you need to make sure that that comma is placed appropriately. And the units for volume here, the grams cancels out. I'm left with cubic centimeters, just like that. And then there is my circled correct answer for this problem. All right. All right, let's see here. We are cruising on through this whole worksheet. So let's see if we can hammer out another few more problems here. Our next one here is going to be number 7. Okay, So let's see what we got for number 7. Number 7, it says, let's scroll this up so we're just looking at number 7 and focusing on just on that one here. All right, perfect. It says our nearest star besides the sun is Alpha Centauri. What is the density of, what is the density? So let's highlight that. That's our question. What is our density? From that, actually, we should be writing down the density equation. So let's scroll this on up here, figure out density is equal to mass over volume. So density equation is density is equal to mass over volume. All right, and it says I have a 25 cubic centimeter sample that is 1,420 grams. So cubic centimeters, what does that correspond to? That corresponds to a volume. Fantastic. So cubic centimeters, volume. Grams, what does that correspond to? Grams corresponds to a mass. Fantastic also. So I've got now my volume, I've got my mass. So then I can plug that into my equation here. My mass is 1,420 grams. My volume is 25 cubic centimeters. Okay, and now I'm going to plug these numbers into my calculator. That's 1,420 divided by 25, and I am going to get 56.8. Okay, I'm looking at significant figures. These trailing zeros do not count because there's no decimal. 1, 2, 3 significant figures and 1, 2 significant figures. The fewest number of significant figures is 2, 1, 2. I'm rounding with that 8. That is 5 or greater. Add 1 to the preceding digit. That 6 will become 8, 7. So 57. Now I need the correct units. And none of these units cancels out. It's going to be grams per cubic centimeter. And we should be able to check that because this is a density. And what are the units for density? Here we go. Grams per cubic centimeter. And so that is most certainly correct right there. So let's have out that whole problem there. Perfect. All right, we've done with that one, number 7. So let's see if we can cruise on to problem number 8. All right, so number 8, it says a sample of Jupiter is 1.33 grams per cubic centimeter. Then it says, what is the mass? So I'm going to have to write down the mass equation. So what is the mass equation? Mass is equal to density times volume. So I'm going to write down the mass equation. Let's see if we got that. Mass is equal to density times volume. And it says of a 50 point cubic centimeter sample. So 1.33 grams per cubic centimeter. What is that? Grams per cubic centimeter? Grams per cubic centimeter, that's density. So that means that this number here, because of those units, is density. Cubic centimeters, what is that? Cubic centimeters, that's a volume. All right, fantastic. Let's get that. This is a volume. So I'm going to plug in both those into this equation here. So the density is 1.33 grams per cubic centimeter times the volume, which is 50, and there's a decimal at the end of that number, cubic centimeters. I'm going to plug this information into our calculator here, and that's 1.33 times 50 with a decimal, and I am going to get the following unrounded answer of 66.5. I'm going to look at these two numbers that I have here and their units, and I have 1, 2, 3 significant figures. And because of the decimal, this trailing zero counts. That's 2 significant figures. The least number of significant figures is 2. That's 1, 2. I'm rounding with that 5. That is 5 or greater. I'm going to add 1 to the preceding digit. That becomes 67. And the cubic centimeters cancels out, and I'm left with grams. So this is grams. And is grams a mass? It most certainly is a mass. So I should be good to go on that problem, number 8. Okay, we have 2 more problems to do. I think we can do it. So hang on and don't go away. So let's see if we can do just 2 more problems, folks. That's it. That's all I ask. 2 more problems. It's kind of like a, yeah. There we go. This one here, it says the following. Let's see if I can get this a little bit straighter. There we go. What is the density? So right there, we are going to find out where the density equation is. Density equation is right here. Density is equal to mass over volume. So I'm going to be writing that down here for this one here. Density is equal to mass over volume. It says of the inner core of the Earth, if a sample is obtained, that is 610 grams and 50.0 cubic centimeters. So grams, what does grams correspond to? What set of units? Grams is a mass. So that means I know that this number is a mass. Cubic centimeters, what is that? Cubic centimeters is a volume. So this is a volume. So I know all the parts. So I'm going to plug in. So mass is 610 grams. The volume is 50.0 cubic centimeters. And I'm going to plug these two numbers into my calculator and then get a unrounded answer. So that's 610 divided by 50, and I will get the following number, 12.2. Okay, this number in the top, that's a trailing zero. That does not count because there's no decimal, 2 significant figures. These are trailing zeros with the decimal. That's 3 significant figures. Those trailing zeros count with the decimal. Cross out the 3 significant figures. I have 2 significant figures, 1, 2 significant figures. I'm rounding with that 2. That's less than 5. Chop the number. So I'm going to have 12. And then I need units for density. Units for density are grams per cubic centimeter. Grams per cubic centimeter. All right, fantastic. That's problem number 9. We only have one more problem to do, and I am most certain that you can actually hang on to just one more problem. All right, so let's see if we can nail this one down. It says, what is the volume? What is the volume? That's what we're solving for. Of the upper mantle of the Earth, if a sample is 167.5 grams and 3.35 grams per cubic centimeter. So the question is, grams, what does that correspond to? That corresponds to a mass. Okay, perfect. So grams is a mass. Grams per cubic centimeter, what does that correspond to? Grams per cubic centimeter, that is a density. Okay, perfect. So let's write that down, density. And it says, what is the volume? So I need to know the volume equation. So the volume equation is as follows. Volume is equal to mass over density. So let's write that down. Okay. Volume is equal to mass over density. So we're going to be plugging in these numbers here. We know what these numbers are. That's mass. That's 167.5 grams divided by density, 3.35 grams per cubic centimeter. All right. So we're going to plug these numbers into our calculator. That's 167.5 divided by 3.35. And I'm going to get the number 50. Just like that. And this number here in the numerator has 4 significant figures. This number in the denominator has 3 significant figures. So I need my answer to actually have 3 significant figures. So right now, this number 50 has only 1 significant figure because that's a trailing zero that does not count because there's no decimal in it. So how do I make there 3 significant figures? Well, if I put a decimal right here, now this trailing zero counts. I want 3 significant figures, so I'm going to have to add another 0. Perfect. So I'm going to have the number that's rounded correctly with 3 significant figures as 50.0. Now I need to have the correct units. And look, the grams will cancel out. I'm left with cubic centimeters. If you want to do this mathematically, it's cubic centimeters divided by grams, cubic centimeters divided by grams. The cubic centimeters and grams cancels out in the denominator. The grams cancels out here in the numerator, and I'm left with cubic centimeters. If you have any doubt, look for volume. And what units does volume have? Cubic centimeters. So that would be correct. Okay, and so I'm going to circle this. It has the 3 significant figures and it has the correct units and cubic centimeters. All right, so I'm going to put this away here. And so I'm going to just zoom on out for this entire worksheet. Okay, and I'm hoping that you have a great idea of now how to solve for density problems. I've shown you many different problems. I've shown you how to solve them, how to use the equations, how to write the units, and how to round them correctly. So I hope that this was very helpful. And thank you very much for your close attention. Please like and subscribe. And I am the Crazy Hat Chemist. Pencil drop. See you next time. Thank you very much. Bye for now.